Hey everybody, this is Mr. Munson, and we're looking at, again, Unit 6, which is similar figures, and in 6.3 we're going to specifically look at triangles. And just like when we were back in congruent chapter, we had a brute force method to show figures are congruent, and when we talk about figures, we're talking about polygons and things like that, triangles. And then we found in one specific section that there was actually some shortcuts we could use to find that triangles were congruent. Well, we're in a similarity unit, not congruent, but what we were finding is in this section is that there's some shortcuts that will save us the time of using brute force, showing all the angles are congruent and all the sides are proportionate. There's going to be some shortcuts we can use to show that the triangles are similar, which once we know the triangles are similar, then we know that we can write relationships between their sides, and also that we know certain angles will match up and be congruent to each other. So let's get started. Well, just like it stated in 6.2, we did our vocabulary back at 6.1 for this entire unit. So we're going to be looking at some things that we talked about in our vocabulary in 6.1. And so if you haven't done your vocabulary, go back to 6.1 and watch that video and write down your vocabulary. Here we go. By the way, in the 6.1 video, just in the description box down below it on YouTube is a link to a vocabulary sheet. So you can write it on there after you get that done. Let's move on. Okay, so it says I can identify similar triangles by AA similarity. That's one of our I can statements. So this is a theorem that allows us to do that. AA stands for I have two angles in one triangle that match two angles in another triangle. And if that's true, then the two triangles become similar. And the reason we'd want to know that is that once we know the triangles are similar, then we know their corresponding sides are proportionate. We can write ratios that equal ratios. Any missing angles can be identified as being congruent and all those things. So basically the theorem says if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. And so that's my if-then statement in symbols down there to the left. Let's move on. So here's a problem that says choose the pair of triangles that are similar by the AA similarity. So what we're doing is we're looking at A, B, C, and D. Put me on pause and see if you can identify which triangles you'd be able to use AA similarity. Basically, you know in the triangles there are two angles. Put me on pause, then come back and check your answer or get help. Okay, so I looked through all these problems and I need to know two angles in one triangle are congruent to two others. In A, I only know one angle is congruent because of the 15 and 15. In letter B, I don't know any of the angles. In C, I could find some missing angles first, and then once I did that, I identified, yes, indeed, there's a 25 in each, and there's a 65 in each, as well as a 90 in each. And then D, again, I only know one angle, and there's no way of finding the other one. So I'm going to go with C. I hope you did too. All right, let's take a look at this example number 2. Again, put me on pause, see what you can figure out, and find out if you have enough information for angle-angle similarity. All right, well, I found that easy enough. Now, just using vertical angles, I know that there's the 61s matching up and the vertical angles are congruent. I don't know what the measures are, but those are freebies. So now it's just a matter of writing my similarity statement. If you didn't do that already, take me and put me on pause again and see if you can do that. Okay, so I used my the same kind of method I used when we were dealing with congruent triangles. I just followed the same path, HGF. HGF starts with the marked vertical angle to the 61, then to the F. And then, oh, I got the completely wrong answer. Let me fix that. There we go, HTS is what I should have. And so I just basically followed the same path HGF does in the one lower triangle with the one in the top triangle, just going from the marked angle to the 61. And then to the unmarked angle. Let's go on to the next one. Wow, here's a pretty blank problem. Is there really going to be enough information here for us to identify that these two triangles are similar? All we know is that those two lines are parallel. So let's go ahead and see if you have enough information, mark it up, and if so, state the reason why. All right, so I just kind of wrote it up in words since I didn't have letters. Triangles are similar by AA similarity. Double marked angles are congruent because of alternate interior angles theorem. And then the single marked angles are congruent because of the vertical angles theorem. And certainly this other pair of angles are congruent because of alternate interior angles. But really just finding two is enough. All right, well, here we are. Oops, it looks like something got cut off here. Let me fix it. All right, so we have another theorem here. It says I can identify similar triangles by side angle side similarity. Notice that similarity symbol that comes after those statements, and that's going to be really important that you put that down, because if you just put down side angle side, that means you believe that the triangles are congruent. But you have to put that similarity symbol there to show that your understanding is they're just similar. One's larger than the other, and so on. If an angle of one triangle is congruent to the corresponding angle of another triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Let's take a look at what that means. So I've got this angle down here, angle A and angle D. So that's the first thing. That's the pair of angles that are congruent. That stands for the A. Now we're looking at the sides. The sides have to be proportionate. So if you look at AB and DE, over here I have a fraction that represents that. So then AC corresponds to DF, and I have a fraction that represents that. And if those had numbers in them, I'd put them in there and see if those two fractions equal each other. The easiest way for me to check to see if two fractions equal each other is just simply cross multiply and see if they equal the same number. If they do, then the two sides are proportional, and we have ourselves a side angle side similarity. Let's see if we can use this in a real problem. So I suspect this is a side angle side problem. So what I'm going to do is I'm going to first chat and see that I have a pair of angles that are congruent, and indeed I do. Now I'm going to check the side. Sides are proportionate. Okay, so you might be asking, how did I know to take 9 and relate it to 21? Well, we talked about this in class. The smaller side is going to go with the smaller side, and the medium side goes with the medium side, large side goes with large side. So I'm only have two sides here. So the 21 can't possibly go with the 18 to have any chance of this being proportionate, right? 18 is the larger of the two sides in the top one, so I matched them up. And when I cross multiplied, I got 378 equals 378, and that means that the two are similar. Now that they're similar, I can write a similarity statement. Hopefully you got that right. Let's move on. All right, try your hand at this one. See if this is proportionate, or if this is similar by side angle side similarity. Put me on pause and come back and check your work. All right, actually the sides end up not being proportionate, so I do not need to write a similarity statement. These two triangles are not similar. All right. We have another shortcut here. I can identify similar triangles by side, side, side similarity. If three sets of corresponding sides of a triangle, of two triangles, are proportionate, then the triangles are similar. We don't even need to know the angles, right? So if I take a look at this, I'll see that if I take AB, which has a purple arrow pointing to it, and it's related to DE and so on, and these three fractions all equal the same thing, then the triangles are proportionate. Okay, and then we just write a similarity statement. If I have said congruent statement in any time in this video, I apologize. We should be using the words similarity statement, so I'm sorry for any confusion. It just happens. So make sure we're doing that. Here's the thing. Until we have a similarity statement, how do we match up the sides to see if what is the sides I'm supposed to relate? Keep in mind, smallest side goes to smallest side, medium goes to medium, and large goes to large for you to have any hope of the triangles being similar. All right, let's do some problems. All right, let's take a look at this one. So now it's just a matter of setting up our proportions and checking to see if they all represent the same thing. Put me on pause, check it. So I always do these problems the same way when I'm doing this. I just write across the top the sides in order from smallest to largest, put an equal sign and then a line underneath them, setting up for the fraction. And then I go to the second drawing and I write those sides in order. I don't care what angle it's across from. It doesn't matter. If I have any hopes of this being similar, then the shorter side has to go across from the shorter side. Okay, so let's check these fractions. All right, there I have it. String of fractions, 14/5 is across it, so we know that these are similar. I could turn it into decimal. I like doing it as a fraction for you right now because when we talk about scale factor, it's always written as a ratio, a number over a number. It's never written as a decimal like this. And so I just want to make sure that you understand how to reduce fractions. So if you don't know how I got this 14/5 from 42/15 and so on, quick and easily from a calculator, you need to see me and I'll show you how to do that. Here's problem example number 7. Okay, so first of all, do you even see two triangles in that problem? If you don't, that's going to be the first jump for you, okay? Now, the steps I would want you to do with me on this, and I'm going to do this right with you, is I'm going to take that triangle, I'm going to bust it up into two triangles and try to draw them very similar to the way they are. So I have the bigger triangle, which is L, M, K, and then has this from K to L. From K to L has a length of 88. Okay, and then from K to M, I'm going to have to do some calculations and add those two things together. And I end up getting 132 for that. Okay, that's a place where a lot of students make mistakes. They call it either 107 or 25, and that's only part of the triangle. Okay, so now let's look at the smaller triangle, which is represented right here with this green. So we have K, B, and C, and this side's 25, 16, and then some unknown. Okay. All right. So now, it'd been nice as if we had all three sides for this triangle, but we don't. Okay, so what are we going to do? Well, here's what I do know is that I'm not going to be able to use side, side, side similarity. That's what I wanted. But in this problem, I don't have all three sides. So I need you to see something very quickly. Look at K. K is the same angle in both of these triangles. So K here is the same K down there. By the reflexive property, we've used the reflexive property for lines. We're using it now for the angles. By the reflexive property, those two angles, two different triangles, but the same angle, K and K, they're congruent to each other. So I want you to pause for a second, put me on pause, and see if you can figure out a way to show that these two things are similar. I'll give you a hint. It's not side, side, side similarity. So I suspect this might be a side angle side similarity. Let's check it, okay? If you didn't think about side angle side and I had to tell you that, put me on pause again and check your work. So I certainly have the angles congruent by the reflexive property. They're the same angle. And so now I'm going to check to see if the sides are proportionate. Matching up smaller the sides to the smaller the sides and so on. All right, so it looks to me, once I cross multiply, I end up with 2200 and the other one's 2112. And so that tells me the sides are not proportional and therefore this is not similar. Okay? All right, try your hand at this one. So you're going to bust up the triangle into two triangles, put the information into it, and have at it. Okay? See if you can come up with a reason why these triangles are similar. Okay, so there's my two busted up triangles. So if you've gotten this far, just check your numbers and see if it's the same as mine. If you need the hint to see how I got those smaller sides for the smaller triangle, take a look at my math. And now I'm going to work on checking the proportionality, matching up smaller sides with smaller sides and so on. I just want you to know I never look at their position. I only look at smaller side goes to smaller side and larger side to larger side. So I wrote my blue numbers in order from smallest to largest and did the same thing with the red ones. And I'm going to check them with either as a fraction or a decimal. Okay, so these two triangles are similar. And so I can write a similarity statement. And there you have it, two triangles that are similar. Let's move on. All right, so here's three problems, and I want you to decide, which one, if any, work to show that these triangles are similar. Put me on pause, do all three, figure out which one you're going to use, and if it doesn't work, it doesn't work. But if it does work, let's say that they're similar. Okay, there you have it. I haven't done the last one, I just realized, but I'll go ahead and answer this one. So the first one is the angle-angle similarity. I went and found one of the other angles. I know that the 35 is going to be vertical, and that's good. The other one's 45, so now I have two angles. I could care less about the third one. And by angle-angle similarity, those two triangles are congruent or similar. In the next problem, I suspected this was going to be a side-side-side similarity deal. I set up my proportions. I got to comparing the first two fractions, and they failed, so I didn't need to go any further. Those are not similar. Put me on pause and I'll get the next one. And there you have it. I have a pair of angles that are congruent and then the sides that are wrapping those two angles. I wrote proportions between them, matching up small with small and larger with larger, and it ends up being the same thing. So those This one here is by side, angle, side, similarity. And those are our only three shortcuts in this section for showing triangles are similar. Okay, cool. So let's move on. Hey, by the way, before we do, just to let you know, I anticipate having a bonus after the try it problems. So once you get to the try it problems, put it on pause, do the try it problems, but then come back and finish up the tape and see where the bonus problem is. So hopefully I'll remember it this time. All right, so why do we care if triangles are similar? The reason is because once we prove the triangles are similar, in this case it's angle-angle similarity, then we recognize that the sides are similar or are proportionate. And so that allows us to start solving problems like I showed you at the very beginning, in the very first section. We look at these two triangles and we find that they're similar. Here's how I know. Here's a vertical angle in these drawings, okay? So that's the beginning of it. This guy hopefully is standing upright, and the hole in the level plane is a right. So now I have two angles that are congruent to each other. Now that the two angles are congruent, I can now state that these two triangles, the one here and the one here, are similar, which now allows me to start writing that the sides are proportionate. If I know the sides, then I can find out how deep this is. Okay, so I could write a relationship. I could say, his standing upright 6 feet, which is across from the vertical angle, is related to how deep the hole is. And then how far he is from the hole, too, is related to how wide the hole is. And so that cross multiply, and I can solve and find out how deep this hole is without ever having to climb down it and see how deep it is. That's pretty brilliant. All right, let's take a look at our try it problems. There you have it, 3 problems. Have fun with those. Make sure that you follow the directions at the top. Show me the A, B, and C section of your answers and that it's clear, and get full credit. Okay? All right, have a great day, you guys. And there you have it, another bonus. Public Works personnel wanted to find the distance across a water retention pond after a recent storm. They choose to measure indirectly, that's what I just showed you, creating the situation shown in the diagram. What do they call the distance to be? Okay, so what I'm going to suggest you do is, first of all, recognize that these two triangles are going to be similar. I just showed you an example of that, but I'll just tell you that these two triangles are similar because they both have a right, okay? And there's the shorter one up front, right? So this one's here, and the longer one's there. So they're both right, and they share this angle. By the reflexive property, they're going to be congruent. Okay, so definitely we know these two triangles are similar. Now it's your job to find out what x is. Good luck. And I'm sorry, make sure you put this on a separate piece of paper. This needs to be separate. We'll just call this, we'll call this the bonus double triangle. Cool. See you next class.